Hello everyone. Our focus for this video is the double angle formula, or what you call the double angle identity, right? But what we are going to do is to use some knowledge that you would have had to derive this formula. Now, let's say that we have sine of x plus x, right? So we have sine of x plus x. How do you use the sum formula for sine to expand this? Then this is just equal to sine of x cos of x, right? Plus cos of x sine of x, right? But how can you simplify these two things, right? How can you simplify this? If you try to simplify this, you can view this as this is just 1 sine x cos x, don't you? And this is another sine x cos x, despite it write cos x sine x, right? So if you have 1 sine x cos x plus another 1 sine x cos x, how much sine x cos x you have? Then I can say 1 plus 1, that's just 2 sine x cos x, right? But if I combine this side, this is just x plus x. So x plus x gives me what? Here I would have sine of those x plus x, that's just 2x, so that's just 2x here. And that's the double angle identity or double angle formula for sine 2x. Sine 2x is equal to 2 sine x cos x. Isn't that interesting? Alright, so let's just highlight that. So that's 1 here. Alright. Now, let's say that we have cos of x plus x. Do you think this is going to work to be? If we expand this, this gives us cos x, because this is plus, this is minus sine of x, sine of x. Alright? What if we combine this side? We're trying to solve both sides, simplify both sides. X plus x is what? That's just 2x, so this is just cos 2x, right? What if we try to combine this side? What is cos x times cos x? Cos x times cos x, that's just cos square x, don't you? Because if you have this in real life, if you have x times x, that's just equal to x squared. If you have 2 times 2, that's just equal to 2 squared. If you have cos x times cos x, that's equal to what? Cos. That's just equal to cos squared of x. Minus sin x times sin x, that's just equal to sin squared of x. Wow. And that is the double angle for cos 2x in terms of cos and sine. So this is just cos square x minus sin square x. So this is one version of it. So let's just highlight that. Now, let's say that you only want this cos 2x only in terms of cos. You only want this side to be in terms of cos. How do you think you could go about doing that? Now, you know that cos squared of x plus sine squared of x is equal to 1. So what is sine squared of x? If you manipulate this to make sine squared of x the subject of the formula, sine squared of x is just equal to 1 minus cos squared of x. Now here I have a sine squared of x, so I can replace this sine squared of x with 1 minus cos squared of x. So let's just write back this identity here. So we know that cos 2x is actually equal to cos squared of x minus sine squared of x. But we only want this side to be in terms of cos only. So this is equal to cos squared of x minus, what is sine squared of x? Sine squared of x is just 1 minus cos squared of x. So we substitute 1 minus cos squared of x. Right? If we expand this, if we distribute this negative sign to all of this inside of the bracket, that gives us cos squared of x plus negative 1 outside of the bracket. So this is just negative 1 times 1, that does give us minus 1. Negative 1 times negative cos squared of x, that gives us plus cos, gives us plus cos squared of x. Right? Now you have one cos squared of x here and another cos squared of x here. You can add them together. So our final answer would be cos squared of x plus cos squared of x. That's just 2 cos squared of x minus 1. So that's another identity. That's another version of cos 2x. So cos 2x is actually equal to 2 cos squared x minus 1. That's beautiful, right? Maths is becoming beautiful. So that's another identity or another version of cos 2x. And there's 3 versions of cos 2x. And I'm going to show you them. Now, bear this in mind here. What if I want cos 2x strictly in terms of sine only? Here, I can replace this cos squared of x, right? Because what is cos squared of x? From this identity, which is sine squared of x plus cos squared of x is equal to 1, you can manipulate this and make cos squared the subject of the formula. And cos squared of x is just equal to 1 minus sine 1 minus sine squared of x. That's what cos squared of x equal to. So now if I want to write cos 2x strictly in terms of sine squared of x, I just need to replace this. So I'm going to write back this mother one here. So I'm going to write back cos 2x is equal to cos squared of x minus sine squared of x. That's it, right? Now I want this side to be strictly in terms of sine, so I keep my cos 2x, that is equal to, replace what cos 2x is. Cos 2x is just 1 minus sine. So this is just 1 minus sine squared of x minus, put my bracket here, minus sine squared of x. Right? Kind of running out of space. So here, this is minus sine squared of x minus sine squared of x. If you have minus 1, that's equal to what? Minus 2, right? If you have minus 1x minus 1x, that's x, that's just equal to minus 2x, right? So view the sine squared part as an x, and we have 1 here. So this is just minus sine x, sine squared of x minus sine squared of x. You get what I'm saying there? So this can be further simplified to this. So cos 2x is therefore equal to 1 minus 2 sine squared of x. And that is the 3 version of cos 2x. Isn't that beautiful? So we take what we know, which is a sum formula, and from the sum formula, we applied it, and we generate sine 2x. So sine 2x is just 2 sine x cos x, and that's just 1 version. But for the cos 2x, that's 3 version. So cos 2x is actually equal to cos squared x minus sine squared x. Cos 2x is also equal to 2 cos squared x minus 1. And cos 2x is also equal to 1 minus 2 sine squared of x. Let's look at the double angle identity for tangent as well. So you would have known that if you have two angles and you have, say, tan of A plus B, then this is actually equal to tan of A plus tangent of B all over 1 minus tan A tan B. That's what you know, right? So what if you had, I'm going to use x in this case. What if you had tan of x plus x? What do you think this is equal to? Tan of x plus x is therefore equal to tan of x plus tan of x, all of that divided by 1 subtract tan of x times tan of x, don't it? What if we try to combine this side? What is x plus x? X plus x is just 2x. So this is equal to tan of 2x, right? What if we simplify this side? This is tan x plus tan x. But this is just one tan x plus another tan x. So how many tan x is that? That's just 2 tan of x. You clear there? All over 1 minus, what's tan x times tan x? That's just tan squared of x, don't it? So all of this is become tan squared of x. Alright? So the double angle identity for tan 2x is equal to 2 tan x all divided by 1 minus tan squared of x. This is beautiful, right? Taking what we know to create what we don't know. So this is the double angle identity for tan 2x, right? So tan 2x is equal to 2 tan x all divided by 1 minus tan squared of x. So in summary, your double angle formulas are sine 2 of 2x is equal to 2 sine x cos x, right? For tangent 2x, that's just equal to 2 tan x all divided by 1 minus tan squared of x. And for cos 2x, that's equal to cos squared of x minus sine squared of x. That's one of them. It is also equal to 2 cos squared of x minus 1. And it is also equal to 1 minus 2 sine squared of x. So there are your double angle formula in summary. Thank you for watching and do enjoy the rest of your day.